Good afternoon. My name is Maggie Grable, and I studied the effects of potassium phosphate on invasive zebra mussels in the Tennessee River. For background, they were first reported by the USGS, or the United States Geological Survey, for Tennessee in 1992. Since then, they've been permanently established in the Cumberland Rivers and Tennessee River. And instead of reducing their population, I was hoping to find a less concentrated way to reduce their populations instead of trying to fully eradicate them, which is not possible at this time. Here's the map that the U.S. Geological Survey currently has. Those are the sites that are officially reported, but I think there's far more than that because they were literally everywhere on the spot where I collected them. Key references. We have the U.S. Army Corps of Engineers Chemical Control Guide. It was like the most important document I had for this research. It provided a list of all the chemicals that were currently being used. It provided the concentrations that are industry standard, and it also had some of them had effects on native wildlife like fish, but not all of them did. And the gap showed that there is currently no standard single chemical being used, and there was no data provided for if other concentrations could be used. There is the practical manual for zebra mussel monitoring and control. That one has the groundwork of the processes for applying the chemicals. So for example, some of the chemicals, it's like a one-time application. So you just dump the chemical in the water and it'll do its job. Some of them are continuous applications. Some of them require specialty equipment that generates the chemical. For example, the chlorine generators. And that one also did not include any extra concentrations of each chemical. The toxicity of candidate molluscicides paper, it listed the concentrations that were being used for chemicals, particularly for my case that used potassium phosphate. And again, it did not have the multiple concentrations being used. And so my research question is, what concentration of potassium phosphate is the most effective in managing invasive zebra mussels in the Tennessee River? Chemicals that I eliminated are usually, there's two categories. There's ones that have extreme collateral damage, and the ones that have really expensive ways of managing them. So for collateral damage, anything copper-based, it destroys any invertebrates, so crustaceans, native clams, etc. There's ammonium chloride, which is very toxic to fish. And for extra consideration, there's chlorine dioxide generators, which are at lowest a few $1,000s, and that's for a really small operation. And then ammonia is already produced by fish and the zebra mussels themselves, so it's kind of an unpredictable factor for research. And so what I ended up going with was potassium phosphate. It is non-toxic to fish, it is toxic to zebra mussels, it interferes with their gill plates, and makes them basically unable to breathe. So my hypotheses were, if a lesser amount of potassium phosphate was applied to the zebra mussels, then the chemical will still be able to have an effect on them, being able to curb their spread without, to minimize the effects that could possibly happen on any native mussels. And if true, treatment of overwintering zebra mussels could also help reduce populations between peak seasons. So if they're especially weak in the winter, if you target them then, you can get rid of their population then, and they will have less chance to grow over the summer, when they're most potent. So my first round of testing was with potassium phosphate in 10-gallon buckets. The chemical amounts for each are shown there. And I did intervals of 20% just because smaller intervals would have way too many buckets, and also there's a smaller difference between each one, so the 20% increments seem to be the best. And the problem I had with this one is the acclimation process. When I first picked them up from the Norris Dam Marina in Knoxville, I collected about 500, a couple hundred. And out of that, after the acclimation period, about 24 hours, only 44 survived. And that's not a lot for testing. And after treatment, all of those were dead as well. So at that point, I had no data because, and I hypothesized that because I gathered them in mid-February, they're in this overwintering process and we're thus weaker and more susceptible to, one, being put in a new environment, and two, with the mosaicide chemicals. And so I had to revise my hypotheses. And I hypothesized that potassium phosphate has a different pH than the Tennessee River does. So, does that relative acidity have any effect on zebra mussels? To do pH testing, I purchased one of these kits. They're usually used for aquariums. And I would take 5 milliliters of each water sample, add 5 drops of the test solution, shake it, and then compare the results to the guide paper. Here are those results. It's hard to see, but trust me, the colors are there. So the 100% had about a 7.4 pH, 80% and 80 to 60 had 7.8, 40 to 20 had about 8, and the control group had about 8.2. Here's the data for that. In all cases, any concentration of the potassium phosphate did seem to reduce the pH. The strongest of those being between the control group of plain water and the 100% test group, which is a difference of 0.8% or 0.8 pH. So basically for the mortality section, the findings were inconclusive because, one, there was a small sample size, and two, all of the specimens died. So there is not really any conclusion that can be drawn from that. However, the effects of pH are able to be seen. In the 100% concentrate, the pH was lowered by 0.8% and did seem to affect the shells, which I was hypothesizing. The 100% shells felt smoother than the other shells. I'm not sure if there's random sampling where some of them just happen to be smoother, but all of the ones in the 100% did have less ridges of the other ones. I also checked, and there seems to be no change in the pH over exposure time. I'm sure that would be changed if it was in a running water system, but in a standing water system, there's no change. Conclusions, potassium phosphate does have some kind of effect regardless of the concentration. It does affect the pH of the water source, and it does seem to negatively affect the zebra mussels with the texture of their shells. The North Dam Marina could be a potential site for testing because, again, the potassium phosphate is not toxic to fish, and when I went there, I could not find any native mussels, and so it would be safe to try working on reducing the zebra mussel population there without harming the native species. For in the future, I would want to try to see if you can get more healthier specimens, so perhaps gathered in the summer, more precise chemical measurements, because I only had a gram-based scale at home, and so I had to round it off to 3 significant figures. And also, I would like to try more concentrations of the potassium phosphate. However, what has changed in the field is that there's evidence that different chemical concentrations could still have effects on zebra mussels, and pH may affect the shell of zebra mussels. Right there. And with pH, there is some value in seeing if any other pH testing would have effects on zebra mussels. So seeing if acidic or basic chemical would have more of an effect on those. And there is a thing with potassium where the higher the temperature, the more effective it is to a certain point. So if someone were to try a similar test with different temperatures of water, they could also see if that there's like a peak temperature where there'll be an optimal time to do the chemical treatment.
All right, Maggie, thank you so much. All right, oral defense panel, question number 1.
Maggie, how did your review of the methods used by scholars in the field inform your selection of a research method process that is aligned with your research question?
I basically used the chemical control guide as my main source of information for this entire project because it is like an aggregated data paper of different papers that have been used. So it sources the Practical Manual for Zebra Mussel Monitoring and Control and the toxicity of candidate molluscicides. And so using all 3 of those, it basically shaped which chemical concentrations can I use and like what concentration is the recommended industry standard, and then what I could do calculations of percents from there.
How do your findings provide directions for future research in the field?
It shows that, like my data shows that there could perhaps be value in looking at chemical concentrations in zebra mussel management, and also seeing if the pH of different areas could affect zebra mussel populations. So this could go beyond the Tennessee River, which has there's a large range of pHs, but about 8.2 is the average. And so seeing if different pHs could affect it between the Tennessee River and other water sources in the Midwest, which is where zebra mussels are most concentrated, to see if those have any beneficial effects for the management.
If you could revisit your research process, what would you do differently and why?
If I could revisit it, I would definitely try to see if I could collect zebra mussels in the summer when they're more potent, or if I could collect them from the Great Lakes, which is where they are most concentrated and where they have the most problems with them. And so they would definitely be easier to find, probably larger than the ones that we found in at the North Dan Marino, and we just have a larger sample size to see if the data that was collected had significance to, yeah.
All right, Maggie, thank you so much. All right, the floor is open for general questions.
So you said that potassium phosphate affects the gills of the mussels.
Mm-hmm.
Do you think that would happen the same way with the native species, or are they better able to get rid of whatever it is that's affecting your gills?
It affects any bivalve, which are the classification of mussels that zebra mussels fall into. And so they would affect native species, but like what I was saying with the Norris Dan Marina, when I went there was hundreds of zebra mussels. They were covering every surface, but like I could find maybe 20 shells of native species. And so it just, the overpowering presence of zebra mussels in that specific location, I think it could be beneficial to try it there.
So you get to spot clean and then let the native ones come back.
Yeah.
So the purpose is to not eradicate zebra mussels, but give the natives more of a fighting chance.
Mm-hmm. Yeah, they're very prolific, and especially in the Midwest, they can completely coat the insides of pipes, make them unusable. They can travel with ballast water in boats, and after they've come to an area, you can't get rid of them. So if you could just lower their population, there's a better chance for native species to be able to thrive.
Is there any benefit to having, I don't know anything about these mussels, but I mean, is there a benefit to them? Why not eradicate?
They're an invasive species, and they can filter, each one, an adult, can filter a liter of water per day. And at densities as high as a few thousand per square liter, they can completely, like, filter an area of its nutrients, like, very quickly. And so that leaves native species with far less resources that they would normally have without the zebra mussels there. And so they're just out competing native species, and native species are suffering because of that.
Is there any other questions?
What's their area of origin?
I believe they are from northern Asia, but they traveled from Canada down into the Great Lakes, and then they've just spread down the Mississippi River from there. And through travel, they've just slowly spread into the south as well.
And do they just attach on? Like,
Yeah.
Yeah. They're little
They use little fibers.
voyagers, yeah. Why the Lower Stamp Marina? Just curious, like, why was that the one?
So I went to Cumberland City initially because my expert advisor, he was like, there have been some reports of like a problem of them being around the TVA sites around Cumberland City, and so we checked around there, we couldn't find anything, and so there was this article I found early on in my research of, I don't remember the guy's name, but there was a local paper that was detailing how the zebra mussel had shown up in the Norwich Dam area, and specifically mentioned Norwich Dam Marina. And so I'm like, give it a shot, we gotta find them. And so they did happen to be there.
So Maggie, I was very interested in how you talked about your first plan for research, just totally, you know, that I think that's like every researcher's worst fear, and you experienced that. So tell me what that was like navigating that, and what you learned about yourself, and what you learned about the nature of research from that experience.
Honestly, I thought my entire research problem, like my entire research was just screwed at that point. But we were talking in class, and some people mentioned that for like other possible like things that could be done to salvage the project. And so some people mentioned that pH could be a factor in it, and so I decided to go off of that and see if it did. So that became the revised hypothesis.
What did you learn about yourself from that? Hard to talk about ourselves. Yeah. To me, that showed quite a bit of perseverance in your
Well, I think it's so great too that you had such a good community around you. So good job, everybody.
That's what it
said. You know,
And the way you delivered it. It happened, but you weren't good.